yz. Okay? Now, the next part is I would like for you to draw me a tree for this situation right here. Tree. If I want to know what capital F is, what does it depend on?
You have 3 branches.
I have X, Y, and Z. Do y'all agree with that? Yes? Okay, now this is the part that's tricky. Remember the idea here. How can I do this? Let me get the problem that was the goal up here. Remember this was our goal? That was our goal, to be able to find the derivative there. If I give you X, or let's say, I knew I was going to have trouble with this. We are assuming that Y, that Z depends on what 2 things? X and Y, right? Agreed? Because that's from here. Now, we did this, we all said that Z must depend on X and Y. Yeah? Now, this is the tricky part that doesn't seem natural, but let's just draw it. You know how the bottom row of our tree always had the same thing in it? Like it was either all T's or all R and S or whatever? I want to make all my branches here have the same values. Now just watch for a second. X depends on X. That's obvious, right? Y depends on Y. That's obvious. This is not so obvious. Y depending on X and X depending on Y. Right? That's not as obvious. But in some sense, if Z is given up here, right? If Z is given, then you could isolate. You could say that Y and X would be left, so Y somehow depends on X. You could also do it the other way. If Z is given, then you could have Y and Z, or X and Y in there. You could say X somehow depends on Y. So these two are not completely out of the realm of like rational thought to think that that would be okay. Let's just see where it goes. All right, just bear with me. What derivatives are possible here? So tell me what derivatives would be possible in this tree.
Partial F.
What's possible is possible would be partial capital F, right?
Right.
Partial capital F with respect to X and partial capital F with respect to Y. Nope, because look, the bottom row is what we're going off of, right? Because if I know X and Y, then I'll know Z and back up. All right, let's look at the partial of F with respect, capital F with respect to X. Let's look at just this one. Partial capital F with respect to X would be equal to, I'm going to go down which branches here? Go down here, right? And then down here, right? And then I'm going to go down here and down here. And then down here and down here, right? Those are my branches. Questions? Okay, let's try this first one. Here to here is partial of F, capital F, with respect to X. What about this branch? Partial X with respect to X. That's like dx dx. What's dx dx? It's 1. So, but that's not going to matter. I mean, we'll get to that later. Then I come down here, partial capital F with respect to Y, and then partial of Y with respect to X. Yeah? And then this one, partial capital F with respect to Z, and then partial Z with respect to X. So it's very similar to what we did before. Yeah. All right, let's write this formula down. This will be what partial, God dang it. What is it? This times this, right? So partial f with respect to x times partial x. I'll write down partial x plus down this way. Partial f with respect to y times partial y with respect to x plus one more. Partial f with respect to z times partial z with respect to x. Y'all still with me? What is this equal to right here? 1, that's a 1. So can I erase it? Okay, that's a 1. Aren't these the same? Subtract it on both sides. Right? I can subtract because this is an addition between those. If I subtract this on both sides, I get a 0, don't I? So I'm going to get 0 equals partial capital F with respect to y times partial of y with respect to x plus partial f with respect to z times partial z with respect to x. Now I know I've kind of taken us on this weird journey, okay? But I'm going to take you back just before we continue here. I want to take you back to our goal. Our goal was to try and look at that and find two different things. Partial z with respect to x and partial z with respect to y, which would be easy to do if we could solve this for z, right? We can't solve it for z, so we're trying to use some sort of implicit differentiation. So I did some weird shit, and then now I'm doing all this, and I've gotten us to here. And you're like, okay, now what? Let's just focus on this one. Do you see that in there? You see it? Yes? Okay. I would like for you to go ahead and solve for that. So take the other stuff to the other side. What do you get? So I'll move this to the other side. You get negative partial f with respect to y times partial y with respect to x equals partial f with respect to z times partial z with respect to x. We agree? Now? Trying to solve for this, right? Divide, so take this, put partial f with respect to z, and then this side becomes this. Yeah? Okay, one more thing. What's it? Yeah? Yes, what? This right here. Right there. Okay, so we're almost there. Hold on, we're almost there. We have you mean like flipping like this? Hold on, let me see what are you going to get if you cancel them?
Negative dz over dx.
Yeah, you're going to get this appearing on the other side, aren't you?
And we don't want that.
You don't want that. What we want is a formula for this that involves something else. So leave it the way it was. On the top we have negative partial f with respect to x over partial f with respect to z. That equals partial z with respect to x. Let me just double check that I got that. Partial f negative x, partial f. Okay, perfect. All right. So that's a formula for this. All right? Box that up. That should be something you have copied down somewhere. It's in the book also. Now, I'd like for us to go back to the tree that we just had. And let's talk about that other derivative that we could have found. You remember the tree? It was f, x, y, z. You have this written down, so. We had done a formula for partial f with respect to x just now, right? We could go with respect to y now, if we wanted to. And that would take us down here, 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 right? Can we write a formula out for this then? Partial f with respect to y equals, so come down this way. Yeah, this way. So partial f with respect to x times partial x with respect to y plus partial f with respect to y times. Are y'all following me, or am I just talking to myself up here, right? Are y'all still there? Okay. Partial f with respect to z times partial z with respect to y. That's what it would be. And look, what I'm trying to get at now is, can we get a formula for this? Do you see that in there? See it right here? Right? Do you see that? Can you isolate that? So which one of these is 1? This right here is a 1. And when I subtract this on both sides, right, this one, subtract, I get 0 again. Very similar to what just happened a second ago. So 0 equals partial f with respect to x times partial x with respect to y plus partial f with respect to z times partial z with respect to y. And then move things around and solve again. And you should get a formula. Anybody have it? Want to go out on a limb and tell me what the formula is for partial z with respect to y? What do you got? Negative partial f over partial x over partial f partial z. Who's in favor of that? All of you? No. Yes? Yeah, that's it. Negative partial f with hold on. Hold on. No. This is y. This is y right here? Yeah, this is y. Do y'all see that? Okay. So we agree with that? Yes? Okay. All right. So that's it. You got them both boxed up? I'll write them down over here. Partial z with respect to x equals negative partial f with respect to x over partial f with respect to z. Is that correct for that one? Yes. And then this one, partial z with respect to y equals negative partial f with respect to y over partial f with respect to z. Those are our two formulas. And now let's go through and do this problem. How much time do I have? 20 minutes. Perfect. All right. What we'd like to do is take that and find these two partials. Right? The first thing I'm going to do is move everything to one side and make it look like this. Bring everything over. Minus 1 equals 0. Okay? Is that all right? Yes? Minus 1 equals 0. This right here is capital F of x, y, z. Let's find these two things. So let's start with this one. What's the partial of z with respect to x? According to our formula, it's the partial of this f with respect to x, which means what? Partial of this with respect to x. That means we're treating x like the variable, y and z as if they're constants. So I'm holding y and z constant and looking at just x being the variable. What is the derivative of this if x is the variable and y and z are constants? So what's the derivative of that? 3x squared. So negative, let's do negative. 3x squared. What else? 0, 0, and then plus 6 yz. Okay? Got it? And then over the partial of f with respect to z, which is the same thing. You're going to let z be your variable and let x and y be your constants. So 0, 0, 3z squared plus 6xy. We good? Distribute negative 3x squared minus 6yz over 3z squared plus 6xy. There it is. That wasn't so bad, was it? Do you see how quick that was? Okay. Now we could do the other one. Let's do partial z with respect to y. So we're going to do partial of f with respect to y with a negative out front. So how about that? What's partial of f with respect to y? 3y squared plus 6xz over, now the partial of f with respect to z, which we already did, didn't we? 3z squared. You see how quick those two were? Now that we have the formulas? Now I want you to appreciate that, so I'm going to make you appreciate that right now. You ready? I'm going to act like those formulas didn't exist, and I'm going to do the same thing. I'm going to find this one right here by going about it the harder way. Here it comes. You don't have to write this down. Let's just see it. I'm going to take the partial of z with respect to x. So that means I'm going to treat y like a constant, z as if it depends on x, and x as if it's my variable. So what's the derivative of this? 3x squared plus derivative of that plus derivative of this, partial z with respect to x, plus derivative here, product rule, right? So derivative of this with respect to x, which is 6y, times z, plus derivative of z with respect to, or partial, z with respect to x, times 6xy. I'm going to run out of room. Do you understand that that was product rule right here? And then derivative of negative 1 is 0, equals 0. Equals 0. Now let's isolate these. So everything that's not those to the other side, which is what? This piece and this piece. Let's take it to the other side. So that would be negative 3x squared minus 6yz equals whatever was left over here, 3z squared partial z with respect to x plus partial z with respect to x. I know I'm working through this fast, but I'm hoping you're just following what I'm doing. What can I do on this side? Factor out. So partial z with respect to x, and then I'm left with 3z squared plus 6xy equals this side. Divide this over. Does it match? Does that match this?
Yes.
Yes. See, that answer matches this answer? I would argue that this is a little more work once you have the formula, right? And this can get really complicated now, and this is much easier to calculate than that one is. So it's kind of a shortcut for taking derivatives of equations of two variables. Equations containing three variables. All right, we got about 10 minutes, but I think that's probably good for 11:05. What do y'all think? Yeah? I'll give you some time. Let me look over this thing here. So on number 4, on your take-home, number 4, you see number 4 on that take-home? Anybody not have a copy of the take-home? There weren't any extras floating around? Raglan, you got a copy? Yes? The take-home, the new one?
The new one, no.
No? There's not another one? Okay, here we go. So if you look at number 4, number 4, find partial z with respect to x, right? Looks a lot like this, right? Partial z with respect to x. So you can do that the hard way, or you can do it the easy way. Or you can do it both ways just to practice. All right? Number 1 on the take-home. Okay, so on number 1, you're looking at a domain problem, sketching the domain. I think that's straightforward. There's no magic to that. Number 2 also is just practicing some partial derivatives. And those are higher order derivative. Well, no, it's not even, I don't even have you go that high. Partial with respect to x, then y, then xx, then yy, then xy. All right. No big deal there. 3, that's just like a notation thing. Do you understand what that notation means? Like the order of that? Do you know what order to go in? And then 4, we just talked about. 5, equation of tangent plane. You had a problem at the end of class that y'all did, that y'all worked on together, right? Last class? Right? Remember the problem at the end of class last time where you had to find the equation of a plane? And okay, so that's like number 5. And then number 6, that's straight. Does that seem like a pretty straightforward take-home? Yeah?
Well, no, I guess.
You'll know, I mean, it might get kind of ugly once you get in there, but it's not like the last one where it's like the particle moves along a path 4 units and and you're trying to figure out what the hell does the 4 units mean, and like there's nothing hidden in there. It's all direct questions.
We'll find out on Tuesday.
You'll find out when you start Tuesday night. Yeah. Yes.
Wednesday morning?
Are you going to get what? Yes, I haven't touched anything since Thursday. So you will get those back. Yep. All right, everyone. We're going to cut out 10 minutes early. What was what? For number 2? I can tell you what I have. The actual distance from number 2. .29. No? That's what I got, 3.29. No, you didn't get that? Yeah. I can go back and double check. We'll see if anyone gets 3.29. Let me turn this off real quick.
Question about